Okay, so we are now on unit 1.3, which is rates of change. Now, this is going to involve graphing. So this is kind of 2 points. One of this is learning how to do a graph, but the other one is learning how to read a graph. And so one thing to kind of note here is so we can figure out the slope of a line if it's on a graph. So if you're looking at this graph right here, we can figure out what the slope of that is. What is the rise over the run of that based on the points? We just need to use any 2 points on there. And what we do is we need to label these things X and Y. Now, when I give you a point, I'm going to zoom in on here. I'm going to pick this point here that I'm doing in red. Now, down here is our x-axis, and up here is our y-axis. Okay, x, left and right, y, up and down. That's important to note. Now, when I give you a coordinate, you can see this one here. I can see it has an x of 1 and a y of 1 in this case. Now, if I go blue, and let's say I pick this point here, well, that one, this point here, I can see it is 1, 2, 3. It has a x of 3 and a y, it goes up 2. If I give you this green point here, tell me what that is. Think about it for a second. What's the x? 1. What's the y? 3. And so on and so forth. So that's how that works here. So we need 2 points. Now, if I give you 2 points on this line, let's say I use my first one here, my xy, my x1 and y1, but I use the second point here, it's harder to tell which point's which. So when you see these 1s and these 2s here, that just refers to the points. So we're going to make a little bit more sense of this in a second, but for now, our formula here is m equals y2 minus y1 all divided by x2 minus x1. Bigger. Here we go. So if a line is going up, it is positive. If it goes up from left to right, as you can see here, the slope is positive. You read a line like a book, right? I read the words in a book from left to right. I read a line from left to right. Now, if I'm looking at this line over here, yeah, that's not working. If I look at this line over here, I can see as I go from left to right, this line goes down. So this line is negative. Okay? So that's the difference between positive and negative. That's important here. So when I pick these 2 points, remember I need to pick, this is point 1, and this is point 2. When I pick these 2 points, and I'm going to use my red ones here, which is 1, 1, and 4, 4, because these are on the same line, right? So you can ignore the green and the blue. So as I go from left to right, what's the first point I see? Yada, 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 yada. It's 1, 1. So my first point here is going to be 1, 1. Always format it like this. Put the brackets, put the comma. Don't get lazy with it. I promise it's helpful. My next point here, that I've chosen is 4, 4. You could pick any point on there. It doesn't matter. I'm just picking those 2 randomly. Okay, cool. So I have 2 points. So all I got to do is substitute this in. Now, my y2, think about this. Which one? So these are my y coordinates, my 1 and my 4. The y2 is the second y, the second number on the y-axis we found, which was 4. So it's 4 minus my first y, which is 1, divided by my second x, which is 4 in this case as well. And again, minus 1. Okay, so 3 over 3, which is the same thing as my slope is 1 over 1, right? It rises 1 for every 1 that it runs. And as you can see, that's true. I start at 0 here, it rose 1, and it ran 1, and I can see that's my point there. Okay, I hope that makes some sense here. Figure out the slope of this line here. First thing you got to do, it's not as easily identifiable, right? Is you got to pick 2 points. Then use your formula and then substitute. So try and find the formula of this, the slope of this line here. Now I'll give you a hint. Pick 2 easy points. This first point here, what's the coordinates of this? It's 1 and 7. You could pick this point, you could pick this point, you could pick this point, and so on. Pick an easy point though. This is my next easiest point if I wanted. I could use, what is that? 3 and 6, or you could even use this point here. Any of them work. I'm going to use the 2 big points here just because. So in this case, my x is 5, 6, 7. My y is 4. So I have 2 points here. So now try and do that. 3, 2, 1. All right, so my slope, my m is equal to y2 minus y1 all over x2 minus x1. Right, 2, 1, 2, 1. I just want to make this a little small. No, I don't. Right, what's my y2? Think about it. I read this line from left to right. What's the second y? 7? No, that's the x. Remember, it goes x, then y in your coordinates. So this is the second point I see here, and then the 4 is the y value. This is the first y value, which is 7. Now what's the second x? It's 7. What's the first x? It's 1. Okay, 4 minus 7, that is -3. 7 minus 1 is 6. Now let's simplify this. Again, if you're not so good at it, and this is our first time doing a negative, you don't do -3. Again, pay attention to what I'm doing now. You do not do fraction button. You don't do -3, you do the negative button, okay? -3 over 6. Enter it, it simplifies it for you. Now, one thing I want to note is look at how the negative moved. It went from the numerator, the top, to beside it. You want to do that. This shows the entire slope is negative, not just the top number. So this is my actual slope of this graph here. It's -1/2. It goes down 1 for every 2 that it runs. So if that's the case, okay, here's my 4 and 1, 2. Yep, there it is. It works out. Oh, there it is. It works out. So you should be able to see it. Okay, so key terms here. So first off, we have a rate of change. This is the rate at which one variable, one thing, changes compared to another variable. Okay, and I'll give you an example here on the graph above. This one here. For example, the rise changes by 1 when the run changes by 2 in this case, right? It's just showing the rate that 2 things change. Now we also have an independent variable and a dependent variable, and I will talk about these in a second, but so starting out here, what is an independent variable? It's a variable whose value may be freely chosen. Some common examples you're going to see might include time. Oh, sorry, my my mic cut out there. Yeah, what was I saying? Time. Okay, so that's the most common one you're going to see. The other one you might see is a dependent variable, which is a value whose value relies on the values of other variables. What the heck is that? What does that mean? Let's give it as an example. So for example, how much money you make in a day of work. This is dependent. Look at the keyword. this is dependent on a couple things. It is dependent on, well, what's it dependent on? It might be dependent on the amount of money you make per hour, for example. I make $30 an hour, I make $20 an hour, or the hours that you work. So in this case, the dependent value is going to be usually the money. Money tends to be the common one that we use here. Okay? So knowing that, let's go into this graph here. So all I want us to do for this graph for right now is think, what is the independent variable? What's the dependent variable? So I have the distance I've traveled and I have the time I've traveled. Think about it for a second. Which of these two is dependent on the other? And I will give you the answer here. One of these lines is independent and one of these lines is dependent. I didn't give away the answer there. I just picked random ones. So 3, 2. So let's start out here with the dependent one. That's usually the easiest one to think about. Now, the amount of distance I travel, is that dependent on my speed and the amount of time I travel? Maybe. Is my time dependent on the distance I've traveled? So in this case, the distance is the dependent variable. The distance I travel is dependent on how long I've traveled and the speed I've traveled. Whereas you look the other way, time is almost always the independent variable, okay? Now this is important because, I'm going back up the page, the independent variable, I'm gonna make this blue so it stands out a little bit more. The independent variable is always on the x-axis, the bottom of the graph. Whereas the dependent variable is always on the y-axis, going up and down on the graph. Okay, so now let's do the rest of this graph here. I'm going to zoom out just a little bit. So if I were to choose any 2 points, I don't know why it does that, sorry, any 2 points on the solid line and calculate the slope, the fraction will always reduce to 50/1, right? Because that's the slope. Does not matter. Pick any of these 2 points, any 2 points in here, and you calculate the slope using the stuff we did above, you'll always get 50/1. So that's on the solid line here. If you pick any on the dotted line, it's always going to be 75, right? And think about this. What's our variables? Kilometers and time. If I use the solid line here, it's always going to be 50/1. Well, what's the rise? The rise is 50. I'm going up 50 kilometers for every run of every 1 hour that I go, right? So that makes some sense there. Again, this is literally how it's done. This is how you should be kind of plotting it out as you draw this stuff. Don't draw like the staircase, but this is how you count it. So what's the slope? In this case, I'm gonna it's either 50 or it's 75. Now you're gonna notice, why am I writing these differently? Well, there's a little invisible one under this 50, and you can write that. If I tell you, hey, the slope of this line is 50, of this solid line is 50, there's a little invisible -1 or divided by 1 there. So that's just implied. We know what the independent variable is. It's our time. We know what our dependent variable is. It is our distance. So we also can make some equations out of this. Think about this. My distance is dependent on the amount of hours I travel and my speed, right? So the distance is equal to the number of hours and the speed. I'm going to use the 50 kilometers in this case, right? Whereas the amount of time I travel is dependent on, is affected by the distance divided by 50 kilometers, right? So if I say, hey, I want to know how long I've driven if I've gone 200 kilometers at 50 kilometers an hour. Well, as I can see there, it's 4. So that's how you can think about that. You can learn information, make equations out of it. We'll deal with equations more. All right, so let's do a couple of examples. This is asking a couple things. 1, is the slope positive or negative? And then 2, find the slope as a fraction. Now, the fraction here is important. You are always going to be bringing stuff into fractions when you can, okay? So starting out here, how do I do this? How do I, first off, how do I find if the slope's positive or negative? Read it from left to right. As I read this graph from left to right, it goes up. So this one is positive. Question B, is this one going up or down? As I read from left to right, it goes up. It's positive. As I read this line, C, from left to right, it goes down. It's negative. Okay, so let's do the slopes of these. Oh, crap. How do I find slopes? How do I find slopes? How do I find slopes? Remember, this is written, you don't have to write this down. This is written up above. But your slopes, there's 3 steps for it, right? Pick 2 points, write your formula, substitute, and solve. You're going to see that as the template for the entire course, right? Is identify your stuff, put it into the equation, solve the equation. That's most of this course. Where's my eraser? Where's my eraser? Oh, I'm just stupid. Okay, there we go. All right, so first thing, I'm going to pick 2 points. Let's pick some easy points. Here's a point. Let's pick easy points. And here's a point. You could use this, you could look at this like, oh, this is 2 and like 1.5. You don't know that for sure, which is why I recommend try and pick 2 ones that are intersecting between the y-axis and the x-axis. So let's label these points now. I'm going to start with this one. What's the x? 4. So my x, right? You don't have to always write this x and y. I'm doing this because for some of you, maybe you haven't seen graphs in eternity or ever. So my x in this case is 4, and my y is, look at where my mouse is, look at how I'm looking, 3. So this is my second point that I see. Even though I've labeled it first, it's the second point that I've found on my graph as I lead it from left to right. The first point here is, well, 0 and 0. That's still a point. Cool. So I have 2 points now, and I've labeled it. So now what's my formula? Oh, I'm trying to find a slope with 2 points. Oh, it's m is equal to y2 minus y1, all divided by x2 minus x1. All right, so what's my y2? 3, because it's the second point, and it's the y in that point. So it's 3 minus y1, which is 0, divided by 4, which is my x2, minus 0. My slope is 3 over 4, and it's positive, right? That's an easy way to tell if you mess something up is, oh, I know this slope's positive, but I got a negative number. That's an easy way to be like, oh, I made an oopsie somewhere. Now, I can't simplify this any further, so that is my slope. So now you try. Pause the video, try out question B and C, and I will go over it in 3 seconds. 2, 1. All right, so for this one, picking 2 points. First one here, I can see my x is 4. My y is 5. That's my first point. Now I'm going down. This is the only one that's a nice easy one. So it is x is 6. My y is 10. All right. So m2, yeah. All right, my m is equal to y2 minus y1, all divided by x2 minus x1. Okay, and again, for your graded work, you want to be showing your steps like this because even if you make a mistake, you get like all of your marks come from your steps. So you need to be doing your steps, okay? Even if you get the right answer, I need the steps. So my y2 here is 10 minus 5, try 1. x2 is 6 minus 4. Again, I know the slope is positive. If this was 5 minus 10, I would have known I'd be goofing up somewhere. All right, so 10 minus 5 is 5. 6 minus 4 is 2. 5 over 2. Is that right? I can check. So I should go up 5. 1, 2, 3, 4, 5. And I should run 2. Wait, what did I just goof up? 6 and did I? Oh, sorry. Okay. See, this is why it's important to check. My X here is 3. So that, again, always important to check. So my value wasn't 4, it was 3. So it's my slope is 5/3. So that's why you do that check there. Really important. So next one, negative slope. So same thing. What's my first point here? Well, my y is 10 and my x is 0. Now I want to be really clear. This is my first point. It's the first point I see on the graph. So I keep reading it. I'm going to pick this one, which my x is 9 and my my x is 5. Again, easy mistakes to make. This is why you show your work. No, my x is 9. Jesus. Sorry, it's early in the morning for me. My y is 5. Same thing. M2 is equal to y2 minus 1 all divided by x2 minus x1. Right, my y2 is 5, my y1 is 0. My x2 is 9, my y is, sorry, my x1 is 10. Right, so that'll give me 5 over 1 over a negative 1 specifically. Now remember, I got to move that negative over. Now you could pay attention to what my mouse is doing. You could just do 5 over 1. That means the same thing as, you just do, sorry, negative 5 is the slope. But I recommend try and keep that 1 in there. Keeps it simpler. Now let's check our work. Okay, so I should go down 5 for every 1 that I run. So 1, 2, 3, 4, 5, 1. What's going on? Have I made some kind of mistake here? Has anyone spotted the mistake? Yes. This x is 0. This y is 10. I know it's annoying. Oh, I'm taking notes. He's doing the wrong stuff. But these are real common examples that happen. So this is wrong. So I've now changed my points to the correct ones. So same thing. My y2 is 5. My y1 is 10. My x2 is 9. My y1 is 0. So I should get negative 5 over 9. Same thing. I'm going to rewrite that. That's as simplified as it can go. And now we do our check, right? So I should go down 5 for every 9 that I run. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is correct. So that's my final answer. Circle it. Good habit to get into is circle your final answer. Okay. So now we're going to graph an equation. So before anything else, don't read the graph. Don't read the graph. Don't read the question, sorry. Let's go over what makes a good graph. A good graph will use most of the space, will be scaled properly. I'll talk about that in a second. And we'll have a legend and or labeled axes, labeled axes. Okay, so we will show you how to make a good graph here. So let's read the question now. So Williard works in electricity assistance and he works $12.25 per hour. So what's the dependent variable? So what's our two variables here? Let's think about money and time. Oh, time. Time is always our independent variable. So time in, I'm going to put hours, H. Time is always your independent variable, which must mean that how much money I make is my dependent variable. So that's the first thing I've done. Now it wants us, so that's the first one. What's the dependent variable? What's the independent variable? Now I'll write an equation that shows the relationship between the hours worked and income. That sounds more complicated than it is, right? shows a relationship between hours worked and income. Well, your income is your salary, how much money you make times your hours, right? So now we want to graph the equation. Now, before I go into anything, again, what makes a good graph? It's going to use most of the space. So, for example, a good graph might be something like this. You can see it's used up most of this chart. Okay. This is not a good graph because look at how much space that you've left. This is not a good graph because look at how much space you have left. Now, one thing I want to make a clear note here. Graph making is hard. It's a skill. It takes practice. No two people's graphs might be the same. You both might have good graphs, but you might have different graphs. Okay, so let's think about this here. So I want to use most of the space now, which means that I need to be able to fill in a graph here. Now I could just go 1 hour, 2 hour, 3 hour. You could do that. I'm going to space these out a little bit though. I'm going to move this up by 2, just to space it out a little bit more. So this is 1 hour if I've worked 1, 2. This is 2 hours if I've worked 1, 2. This is 3 hours if I work. This is 4 hours if I work. Why am I doing this? Why don't I just do 1, 2, 3, 4, 5, 6, 7, 8? It's less work for you this way, right? So I've spaced it out a bit more. So now same thing. Now I could go up, what's an easy number to go up? I could go up by 10s. I could go up by 20s. What's the easiest amount to go up? Probably how much money he makes an hour, right? So same thing. I could go up. This is 12.25. This is 24.50. This is 36 and so on and so forth. I only have to go up 4 hours. So that would be like here. So this would be my graph then. Not a great graph. So same thing. I'm going to space it out a little bit here. So I'm going to say maybe this is the 12.25. 1, 2. Maybe this is the 24.50. 1, 2. Maybe this is the 36.75. 1, 2. And then maybe this is the $49 here. So now, as you can see, I'm using up most of the space in my graph. All right, so I'm going to draw this in blue just to make it a little bit stand out more. So let's think about this. Now, if I work 1 hour, how much money do I make? $12.50, right? In this case, it's kind of easy. If I work 2 hours, I make $24.50. If I work 3 hours, I make $36.75. And then 4 hours, I make $49. And you can already see the pattern emerging, right? So now how do I graph it? How do I connect it? You don't just do the points. Well, you should be taking a ruler at your end point and a ruler at your starting point. And 0, 0 can be a starting point here, right? If I work 0 hours, I make $0. So at either one of these 2 points is going to be your other point. So take your ruler from here to here, and then you're just going to connect that line. Right? So let's see. Are my axes labeled? They're labeled, but I should still put an X and a Y here. Am I using up most of the space? Yes. Is it scaled properly? Yes. We'll talk about scale more as we go on throughout the class. This was an easier example for that. Now, what's the slope of the graph and what does it represent? So 2 questions here, right? It's asking us 2 questions. What's the slope and what does it represent? First thing is, well, what's the slope? You might just know it immediately in your head, and if that's the case, that's fine. But let's pick 2 points. I'm going to pick this point, which was my X is 4, my Y is 49. And I'm going to pick this point. Sure, why not? You can pick any other point here. It doesn't matter. My X is 2 and my Y is 24.5 or 50. Same thing. Right? Now I have 2 points. My M is equal to Y2 minus Y1 all over X2 minus X1. Right? My Y2 is 49. My Y1 is 24.5. My X2 is 4. My X1 is 2. So I do this 49 minus, actually, no, let's put it all in here, actually, just like this. I haven't shown this yet. 49 minus 24.5 over 4 minus 2. That's weird. This isn't a slope. There's a slope. Or there's a slope. So 49 over 4, technically that is a slope. Yes, that is technically a slope. I would accept either this, 49 over 4, or let's think like, real world. This is measuring how much money he makes for how much hours he makes. Your slope could, in this case, could also be 12.25 over 1. I make $12.25 per every hour I work. Either of these would be fine in this case. Now, what does this slope represent? Well, we just talked about it. It represents how much money you make per hours worked. So how much is he going to make in 5 hours? Well, I could graph that 5 here, but in that case, but I want to show you the way we do this, because what if I asked you, well, how much money does he make if he works 172.3 hours? Ah, that's a little bit harder then, right? So if we were to replace this number with a harder one, you might get a little stuck. So I want to show you the method. So I take what I know. What do I know? I know the slope. The slope is 1225 over 1. Or you could do it this way, 1225 to 1. Either way, totally fine. Now, I also know that he's asking about 5 hours, which is my which value, x or y? My x value. Sorry, I said yeah. So I'm trying to find the y value here. So I'm trying to find this. So my x value, because that's my run, or I can put it over here just like this. So, oh, we've seen these before, right? Take two of the same thing. Oh, I have 2 runs. Oh, I have 2 runs. 1 times something gives me 5. Well, in this case, this one's pretty easy, right? It's 5. 1 times something gives me 5. Well, again, same thing, it's 5. Which means, oh, I just do the same at the top. 12.25 times 5, right? 12.25 times 5 will give you $61.25. And this works for both of these. Now, same thing. We can work it the other way, though. Well, if he made this much money, how many hours did he work? So try it out. Try it out. I'm going to solve it in 3 seconds. 2, 1. Same thing. Take what you know. I know that I have 1225 over 1 is equal to, well, now I know how much money I made, $183.75. And again, you might just be able to be like, well, just divide it by how much money you make per hour. It'll tell you. Yeah, absolutely. You can do that. I like keeping it this way to keep it consistent. It's a nice skill to have. Same thing, 12.25 times something gives me $183.75. How do I find that something? Work in reverse, $183.75 divided by the 1225, 15. So times 15. So that means 1 times 15 is, well, 15. So he worked, answer the question, he worked 15 hours. Okay, last one. Try and draw this yourself. Don't just rely on me. Try and draw it yourself. Use pencil. Okay, so Reg timed himself on a race course. He passed the 300-meter point at 1.5 minutes after starting and the 600-meter point at 2.8 minutes. Show this on a graph. Well, what's my dependent and independent variable? What's my 2 variables? I have distance and I have time. Oh, I have time. Time's the easy independent variable. So that means it goes on our x-axis here, which means that the only thing left is distance. And that's being measured in meters. So I have my 2 points. Now I got to figure out the scaling. I could just do 1 minute, 2 minutes, 3 minutes. Oh, well, then the graph's going to end right here. I'm not using up all this space. So I'm going to space that out a little bit here. I know I need to go up to at least like 3 minutes, right? That's a nice easy number. Pick an easy number. I'm going to go up by threes this time. Sure. One, two. This is one. One, two, three. This is two. One, two, three. This is three. These charts are 10 by 10 in your book, by the way. But you might have to use that graph paper. You might have to draw a graph. I guess I should have mentioned you need to draw these axes here. I will put something in the video here to talk about that for later. Okay. Now, same thing. My distance here needs to go up. I need to go up to at least 600 meters. Sure. Let's go up 100 for each one because that'll still use most of our graph, right? I'm using 6 out of the 10 slots. So 300, 400, 500, 600. You want to use easy numbers. You could go up by like 75s if you want, but let's just use easy numbers. So same thing. Let's think about this. So one is after 1.5 minutes, that's kind of hard to find on here. He goes 300 meters. So let's go to the 300 meters instead. So here's 1.33. Maybe we should have gone up by 2, but I find to eyeball it, right? You're a human, you're not a machine. So you can just kind of eyeball it. This looks like about a minute and a half. Then let's go to 600 meters at about 2.8 minutes. Well, that's pretty close to 3. So let's say right here, sure. And you also know that he's going to be 0, 0, right? So now take your 2 points, your farthest one, your closest one, and draw a straight line through with a ruler. Okay, now technically this graph can keep going. So cool, I've done that as a graph. So what was his average rate in the meters per minute for this? So average rate. Well, that's the slope, right? So now take your 2 points. So m is equal to y2 minus y1 divided by x2 minus x1. Now, my second point here, well, this one here it's already up here. You can label it if you want, right? 2.8, 600. And then this one here was, what is it? It was 1.5 and 300. So my y2 in this case was 600. My y1 was 300. My x2 was 2.8. My x1 was a minute and a half, 1.5. That gives me 300 over 1.3. Not very clean. Let's simplify that. Fraction button, 300 over 1.3. That's kind of brutal, right? So that's a pretty brutal one here. So let's simplify this to 230 meters per 1 minute. Again, if you had something slightly different there, like maybe you wrote literally this or this or this, like you've shown your work, I would be like, yep, that's fine. Okay. So you should be able to do everything here on the practice questions. If you have questions, let me know. Afterwards, you should be doing the review, and then you should be doing the chapter test at the very end of your book.